Let's take a look at a couple of examples as to how to algebraically evaluate a limit. Here we have the limit as x approaches 2 of the rational expression 3x plus 4 over 8x minus 1. So the first thing we always try to do, since this is a limit in which we're approaching a number, is to simply directly substitute that number in, so in this case 2, in for our x and see if we can secure an answer that way. So we'd have 3 times 2 plus 4 over 8 times 2 minus 1. That yields 10 over 15, which you can then reduce to 2/3. So that would be our answer. Now think about what that means graphically. If we were to graph this function, you would notice on the graph that as your x gets closer and closer to 2, and that would be both from the right side and from the left side, that your y value is getting closer and closer to 2/3. So let's look at another one. Here we have the limit as x approaches 1/3 of 3x minus 1 over 9x squared minus 1. Now the problem with this one is when you substitute that 1/3 in, as we would try to do initially, we obtain a 0 in the denominator, and that's a problem. So because that 0 in the denominator does not permit us to get an answer, we need to try another strategy. So the next thing we would try to do is to algebraically manipulate it. So in this case, you'll notice that in the denominator you have a difference of 2 squares that can be factored. So let's go ahead and factor that. We'll keep everything else the same. Notice that so long as we still have variables in our problem, we keep the limit notation, because that basically tells us what operation that we're doing to this expression. So once we have that factored, you'll notice that the 3x minus 1's cancel out. Don't forget you still have a 1 remaining in the numerator. And then we try to substitute in again. And when we do that, we are able to get an answer now. So we have 1 in the numerator. In the denominator, we have 3 times 1/3 plus 1, which in the end reduces to 1/2. Notice that once we substitute in and we no longer have the variable x in the problem anymore, at that point we can lose the limit notation. Now think about what this would look like from a graphical point of view, and feel free to graph it on your calculator if you wish. If you were to graph this original expression you were given and take a look at what's happening to the y values as you approach the x value of 1/3 from both the right side and the left side, you'll notice that your y value gets closer and closer to 1/2. Now in this case, you are going to have a hole in your graph at the location where x equals 1/3, because remember it was the 3x minus 1 that canceled. So remember from your Algebra 2 and pre-calculus days that whichever expression cancels out, set that equal to 0, and that's going to be your location of your hole in the graph. So in this case, we would have a hole at x equals 1/3. The y coordinate of that hole would be 1/2.